Hello everyone, welcome to my first live stream. Today we are going to start a sequence of live streams to cover some technical content, some front-end development, especially some deep low-level technologies without frameworks. Like we are going to avoid using React or Angular or anything like that. And that is going to be a really nice way to us to share some content and to learn how those frameworks actually work and how we can get value from them. My name is Lucas. I have been working in software development for 15 years, and I shifted to work in main front-end part around 10 years ago. So I saw a lot of cool things evolving from the technologies and from different libraries that got popular since jQuery and even vanilla JavaScript until today, single-page applications. So I will save some time in the beginning of the live stream and in the very end for normal chatting and to see, like, to give some attention to people sending messages. Hello, I can see some people already joining. Thank you everyone for being online. And especially the time in the very end will be like for very general chatting, even non-technical things. If you have any questions about other topics, that will be very nice to save that for the end. The live streams, my intention is to have them every weekend, 2 p.m. Saturday, the same time as now. Only if I'm not available or if something really bad happened, we may skip some sessions, but that should be a very solid weekly schedule to cover all the topics we want. And the topics that the topic we have for today, the isomorphic applications, we are probably not going to finish that today. That may take 2 or 3 live streams to cover everything. Otherwise, we would have like a 5 hours live streaming. Probably that would be very tiring to everyone to watch. Also, you see, I see the message video download was canceled. What? Chester, where you see that? You see that on Twitch? I think, yeah, I think Twitch is not, there is some issues with Twitch, but YouTube should be working fine. Thanks for highlighting that to me. As you can see, like I'm sending this stream into multiple platforms, and I would say like what is how the return of each platform is going to be. In the end, the final placement for the videos to be online will be YouTube. That's the main place to watch later after the live stream finish. And I wanted to also create some kind of a shorter version of this live stream, like with cropping out the chatting part and focusing on the main content. So that is probably going to be a easier version to share later if you want to share with friends after the live stream finish. If you are watching this offline, that version may already exist. I'll see if I can add some notification somewhere to point you to that version. Then you don't need to watch the entire live stream. Also, we are going to start the real content of this live stream still. We still have some minutes, like we still have some other topics to discuss before the main topic. So you still have time to share the link with anyone you know. I can see more people joining. Welcome, Bano. Nice to see you around. Also, the main focus, as I said, we are not going to focus on any libraries or frameworks. And even when we jump into other topics after the isomorphics, like I'm preparing content into PWAs, WebSockets, web workers, and other things, but we will also cover those topics with no libraries. So we should be able to go into the very low-level APIs and understand how they work. And then as you choose to use a library, that is only for convenience. You already understand how everything works, and that helps also to understand how those libraries work and why you needed to deal with the libraries the way you need, because underneath they need to have some access to the low-level APIs, but you should be able to understand how those things work underneath. So let me see. I have a lot of topics to go on before we join the main area. Let me see. Yeah. So probably I may miss some messages in the chat if you have some questions or anything. But if someone asks questions and you know how to answer, please help each other in the chat. That will be very valuable, especially if I miss something. But also, as I go into the code and into the project, if you have any questions or any suggestions, let me know. You probably may know other ways to do the same things that I'm doing, so share those things with me. I'm here to learn as much as everyone else. That would be very nice to see, like people with different experiences and other things. I want to learn from you as much as you. Let me see. Quick question for everyone online. Give me some feedback about the audio, if that is going well, if it's too low, too high, or something. Let me see. I can see you, Rafael. Nice to see you in the live. Good. Long time no see. I see a lot of friends joining. That's very nice to see everyone around. Let me do a quick round on all the platforms I'm streaming to see if everything is going well. I think so far most of the platforms are working. Only Twitch is not really happy with the stream. I don't know why, but I think our other platforms should be working fine. Yep, sound is good. Okay, thank you for the feedback. Oh, I see Viet is also joining. Nice to see you around. Shirley also joining. So far, most of people who I know, so my friends are here. Thank you for the support. That's very nice to see everyone around. And okay, I think we should be close to the time where we can join to the real topics of today. That will be isomorphic applications. That is a very interesting topic because it is almost a new way to build systems and web applications. So the main point to understand isomorphic applications is actually to try to understand a little bit on how internet works behind the scenes, like as a user, how your browser communicates with the server, how that communication happens, and why isomorphic may be helpful on that. And to go over, my intention is not to go into too deep into the theory and everything, but is more like to be sure like we have the high level understanding. And I think drawing some diagrams is probably an interesting way to cover that. So I'll hide the chat quickly so you can see what I'm drawing. And this is only as a high level understanding on how the internet works for people who are not familiar with that, or if you are starting your career in the front-end development, that's very, very good to understand that high level. So the internet was originally designed as a very request response way for network, mainly based on HTML. So imagine you have you or some kind of user with a browser, and the user, as they try to access a system or something, the browser will generate a request to the server that will process that request and will generate a response to the browser, normally in HTML format. Okay, so HTML format is a markup that when sent to the browser is able to generate a view for that. So the user can see the result of the rendering of that HTML. And as the user interact with this page, clicking a button, submit a form, other requests are sent to the server, and the server returns a full page again in HTML. So basically, the internet was designed to have this very request response based on HTML. And this HTML was always a full page. So the browser would have always a full page refresh, throw away everything that was there before, and get a total new content displayed. And one of the problems in this approach is because those HTMLs, all those pages, they had a lot of repetitive content, like header, footer, menus, and things like that, repetitive every time in the entire navigation of that user. And that was, especially earlier 2000s, was wasting a lot of network traffic on sending repetitive content. Then the internet evolved, especially with the computers with a better CPU, better networks, better browser engines and things. And we slowly started writing some JavaScript that could run in the browser side, and that's where single page applications started getting more popular, and we started transferring a lot of that execution that used to happen in the server now happens in the browser. So nowadays the single page application is a very common format, and the way that works is you still have the same user, the same browser. In the very first request, you still rely on an HTML page in the same way, but this HTML page tends to be a very, very small page that normally has only a reference to a JavaScript file. And then you transfer those two things to the browser, and that works almost as if you are downloading an application, an app for your phone. And that JavaScript running in the browser now is the one that organizes the communication from that moment on. And then requests are sent to the server would send the response, but now that response would no longer be in HTML. That would be normally in a JSON format. So this JSON format tends to be very small, a very small fragment of data that is transferred back to the browser, and then only small parts of the page would be updated as the user interacts with the page. So you no longer need to do a full page reload again. You would only update those small fragments as the user interacts, and that tends to be a very good navigation. After you have this installation, this download, from this point after, the experience for the users in this format tends to be better. But the problem on that is, until that point, like while you are still downloading this first HTML, this JavaScript, or the first JSON call, the user has nothing to see in the page. So that's why normally single page applications, they tend to have some type of a loading animation or something to give the user the feeling until this first content is displayed. So that's the trade-offs. When we are talking about a server-side render comparing to browser side, the server side tends to be a really good first load, like the feeling that you type the URL and press enter and something is visible to you immediately is very good in the server side. But from single page applications, you would have that better as the continuation, like as you finish this download and you keep interacting with that application, you have a good experience. And the main idea of the isomorphic is actually get the best of both. You would rely in the server-side rendering to get that very first impression, like that the application is working very fast. But you would also get the single page approach where the navigation after the installation is still very good. So basically that's only a high level explanation on what we are going to see today. And from an empty folder now, we are going to write our isomorphic application. So from the chat part, if you guys have any feedback, if anyone understand anything I just explained, please let me know in the chat. That will be very cool. And as we go, let me give some attention to the chat, what people are saying. I see some people are finding each other. Nice to see you all here. Let's see, Facebook is also with some good, some people watching there as well. And very good. So, okay, I think we should be in a good position where we can now start the real project. Like, let's go and start doing things. And you guys can see things in the chat again, and you should be able to see my screen. Let me go to the corner here. You guys can see this is my screen right now. As you can see, I started with an empty folder, and we are going to start from the very beginning. So as I said, if you have some experience in front-end development, this very beginning will be a bit boring to you, but I think that's a very good way to understand from nothing how can you go all the way to a working application. Especially for me, that's a very interesting format, because in the very beginning of my career, like I would join projects where the projects were already there established, and starting from nothing was actually very valuable in that moment. So let's see, I can, the delay for the chat to you to see what I'm saying is like probably a couple of seconds. So I will wait until I see if any other comments. Okay, I can see some good feedback for the explanation. And here we go. The prerequisites, if you wanted to follow what we are going to do here, you mainly need only Node.js installed. Any version after 10 should be fine. And I'm also going to use a TypeScript and Yarn. So yeah, I see some messages. Nice, never bored with development. That's good to know. Then also, okay, so Yarn, TypeScript, Node.js, some kind of browser, and IDE. I'm using WebStorm, but VS Code should be fine. You can also do everything I'm going to do in normal JavaScript. You don't need a TypeScript for that, but I personally like TypeScript because the code completion and the warnings are very valuable. So I don't need to waste time searching why things are not working. The messages are very good for me. Also, let me see if there was anything missing before we start. Okay, so the main idea that we are going to do as the isomorphic part, we will have some code running in the server, we will have some code running in the browser, and we will have some kind of reusable code that will be running in both. So there is a common part that should be unaware of the environment, and most of our application should be in that common part to be shared. And the code that is on each individual environment should be almost like a translation layer for the native APIs of those environments to the common code that we have. One example is, if you need to know the current URL that you are processing, in Node.js, you would rely in a request object to know that. But in the browser, you would rely in the document location to know that. So those translations from the native environments will happen in those entry points for each environment, but the code that we will have in the common area shouldn't be aware of those specific parts for each environment. So the way we can accomplish that is I'm going to create some type of source directory, and inside of this source directory I will create 3 subfolders, one to represent each one of those areas, like server, client, and common. So we can start with server, okay, client, and common. Okay, so those 3 folders should be more than enough as a scaffolding for the project. We will also initialize our Yarn and our TypeScript. So Yarn is a simple Yarn init. I'm not going to worry about any one of those definitions, like all the defaults are fine. And we can also initialize TypeScript. Like the initialization of TypeScript is basically generates the default tsconfig file. So I don't have the TypeScript installed in my global environment here, so I'm going to use npx to run that. But if you have a TypeScript in your global environment, you can run tsc ---- init. Here I'm going to use npx with the TypeScript command and with the init option. So this generates the default tsconfig file. Normally this tsconfig for this type of example project, this type of tsconfig should be fine. We can open that and have a look on what was created. Yeah. So you can see normal tsconfig. We probably can later we can include some libraries here as we needed them, and we may bump the target version later to because we are not really running this code in an older environment. So having that as a more updated version of JavaScript would be nice. Okay, so the very first target that we are going to try here is to have a working HTTP server. So that's the very first target we need to accomplish, because without that working, there's no point of talking about anything else. And the way I wanted to have this HTTP server is by using the native HTTP implementation from Node.js. We could use Express, we could use other implementations, but having that as simple as possible will make the Livestream more like future-proof. Even in future, new libraries are popular. This content should still be very relevant. So that's the point. So we can start with some kind of index.ts here, and the main point to start using this. To have this project running, we will start installing the basic libraries that we are going to use. So, as I said, TypeScript. I will also use a TS node because I don't want to compile everything, especially the server side. Being able to run TypeScript from the command line is very, very simple. And TS node is going to be very important later when we have the browser side. We are going to use webpack there, and as we have a TS node, I will be able to write the webpack configuration in TypeScript as well. That's going to simplify a lot our life. Also, something that will be very helpful as we have some Node.js code in the backend. Having the types node already installed will simplify things as well. And yeah, with this, we should be able to start creating a very basic HTTP server. So I'll start by importing from the HTTP server implementation, the native one. So HTTP from HTTP, that's the basic HTTP implementation. And we should be able to create a server. This reminds me very old times. I saw Rafael Grigorian old times in HSBC working in Java. So this request response reminds me Java a lot, like servlets, where you needed to deal with a request and a response. So that's a very basic format for networking, and the request represents the object that the browser is sending to us in the server, and the response is the message that I am intending to send back to the browser. So as I get this request response, then we can build this message to send back to the server. So in this case, I'm going to say response write, and we can kind of have a very simple test message here. Doesn't need to have anything. This is basically the very earlier test of the server, and we also have a response.end to let the HTTP server to know that we finish this message, so it's ready to be sent to the browser. And we are going to listen in a port 8545. That's a random number that I chose, that I'm sure there is nothing in my computer listening in that port. And to simplify our life, I'm also going to trigger the execution of this project via npm script. So I'm going to create a script execution here. That will be my start project. And the only thing I'm going to do is call ts node in the source server folder. We should be good to test our first HTTP server. Everything should work fine. So if I do a yarn start and I switch to my browser, I should be able to see a test message. And yep, means that our first HTTP server is working fine. This is very basic again, so only to start the process, like nothing really specific for isomorphic yet, but we will get to that point. The second thing that we will need to have is some kind of file library that will be running in the browser side, and that's what we are going to have in the client folder. So we can start creating the entry point for that. I'll call index.ts, and again, as a very small test, only to see if everything works, I will start with a console log client. So this is a very basic console log. My intention to confirm if the structure is working fine is we will need to come here to our browser, and in the developer tools I wanted to see that console log in our log page here. So that's the next target that we want to go, and that is one of the targets that will take a bit longer than the server part, because we will need to generate some kind of bundle from this file. Like we will need to compile that into a JavaScript, and then that JavaScript will need to be served to the browser in some kind of path, and then that will be able to execute. Normally, if I was using Express, exposing that file to the browser would be very simple, because we could use static middleware, and that would work out of the box, but we are not using Express here, so I have some ideas on how we can bypass that limitation. And I don't want to really write a middleware manually to serve those files, but we are going to do some tricks here soon. You will understand what I mean. Let's start focusing in generating the final JavaScript for this entry point. So as I said, we are going to use a webpack, so we can start by installing webpack. So yarn add webpack CLI and types webpack. This should be enough as the installation. Also, we are using TypeScript, so we need a way to tell webpack how to deal with TypeScript. So I will add TS loader, and with that we should be covered. Yeah, no more libraries. You can see I'm installing some libraries here, but everything I'm installing is supposed to run as a build tool. At the runtime, only code that we are writing is going to run. So also, now we are about to create the webpack configuration file, and as I mentioned before, because we have the TS node installed, I can write the webpack configuration file in TypeScript config.ts. And the good point on writing that in TypeScript is because I don't really need to remember all the possible configurations that the TypeScript, that the webpack configuration file has. Like it has a lot of possible configurations, and if we export default object as a configuration, you see that that configuration is pointed as the configuration coming from webpack. And now that I have this definition, it's very easy to me to come here and start getting like a very helpful definition of what we are going to build. For example, I can say, I want my mode to be in production. And we are going to build a production bundle, but I don't want that production bundle to be minified, because we may want to inspect that bundle later, but I wanted the tree shaking to happen, the optimizations to happen, so that's why I'm pointing as a production bundle. But if we go to optimizations, I should be able to say minimize false. So then this is going to be a readable file, but with the optimizations applied. I personally like this type of definition. In a real project, you would probably use the webpack dev server to run and watch files for you, all those things. But here we are trying to have something kind of almost in a working state with the basics. So the point is not to see how webpack works, is to see isomorphic. So I'm going to create the minimum configuration as possible, only to have that working. Also, as part of the webpack, we need to update the entry. Like the default entry for webpack is inside of the source folder, but we have a client folder there, so we needed to reset the entry, and that means that we are going to point to source client TS. So that's where we are going to start the execution. And we also needed to do some configurations to tell webpack about TypeScript specifically. So we needed to update the resolve object to include the extensions, and You can have like a JavaScript, TypeScript, like all the extension files that you want Webpack to deal with. As we are writing out the code here, TS is more than enough. In a real project, this list would have more entries. And in the module part, we also needed to register our TS loader to tell Webpack what to do when they find that TypeScript file. So I'll set up the rules, and that should be an array. And we have here a test. Here is where the test will point to regular expressions. And I'll be honest, I'm very bad with a regular expression, so this is the part where I basically copy and paste. I should take some time to go deeper and understand better how it works, but I end up never doing it. And basically, this is everything we need as a TypeScript and Webpack configuration. With this configuration, we should be able to get the index file from the client folder and generate that as a JavaScript that we will be able to serve to the browser later. And to simplify our life again, I will create another script tag in our package.json, and that is going to be something where we are going to run a build process, and the build process only needed to run Webpack with no parameters. We are able to run Webpack with no parameters because the Webpack configuration file is placed just next to the package.json, and by default Webpack will search for the configuration file in that place. So because the Webpack file is there, then we don't need to provide extra parameters, and we should be able to run yarn build now. If everything is correct, we should be able to create a final JavaScript file in the default output folder, that is the dist folder. Let's have a look here. Yeah, and as you can see, we just generated a dist folder here with a main.js file. We can start inspecting this file to see how it looks like. You can see that the console log that we just created is here. And on top of the page of this file, you see that the Webpack runtime is also created here. This is part of the Webpack itself and helps Webpack on understanding the order of the dependencies, what depends on what should run first and everything. Later, this runtime is going to be one step more complicated as we do more configurations in Webpack, but so far this file should be executable already. We only needed to transfer this to the browser now, and that's the very next step that we needed to do. How can we have our HTTP server exposing this file to the browser? As we mentioned, there were multiple ways to do. We could have a specific check in the request to see if the request is asking for that JavaScript file and everything. But I'll do something simpler for now, where we are going to embed the JavaScript code inside of the HTML. So the code that we are going to give to the browser as the HTML page will already have the JavaScript embedded inside. So I don't need to deal with extra calls to load the JavaScript. And the JavaScript we are building tends to be really small, so that's not going to be a big deal. For a real application production in the company where you are working, you may not want to do exactly like this, but that is, even I saw many applications using this approach for production, so that shouldn't be a big deal. What we are going to start doing here is we are going to generate some kind of HTML page, and the way we can do that is by writing HTML here. So our server is going to generate HTML to send it to the browser. So I can start with HTML. And one trick for WebStorm is, as soon as you write some HTML inside of a backticks string, WebStorm kind of identified that this is a HTML content. So now all the autocompletes for HTML would work inside of this string, and even the emit autocomplete. So there is an interesting way to scaffold some HTML. Like as soon as WebStorm knows that this is a HTML content, then all those autocompletes would work fine. And basically now I don't need to worry about writing this entire content by myself. Let's quickly reformat this code to look better. We don't really need to care much about what is here, but that is a good to have like a proper set scaffold project. Then later we don't worry about other things. Okay, so this is the scaffold. Let me delete the extra tags I created here, and we can let's test this HTML first, only to be sure that it's working. So the way I'm going to test, I'm going to have a header and I write a test. So at least I know that the appearance of the page should change because of this. And with this, I should be able to do a yarn start. Let's check the page. Originally, we only had that text with no style, and now as I refresh the page I should receive the HTML. Let's have a look here in the network to confirm what we are receiving, and that's the HTML we are receiving from the server. Now, as I said, we are going to embed that JavaScript as part of this code. So this code is going to have the script tag, and then inside of this script tag I want the JavaScript from the other file. The way I'm going to do is I'm going to read that file from this execution and embed that code. This is very bad for production environment. Don't do that in a real project. If you are going to read a file like that, you should have the ways to check if the files exist, the security ways to go to the right paths and everything. But again, our intention is to understand how things work. I'm going to load things from the FS. FS is the file system helper libraries for Node.js. And the one I wanted to read is the read file sync. That's the one. So I don't need to worry about callbacks when I read that file. So let's start here in our script. So we should be able to read that file here, and the file we want to read. The path I need to provide is a path going from the root of the project. So we should be able to go to our dist folder and main.js. So what I'm doing here, I'm going to read that file, get the JavaScript, and I'm going to print that JavaScript as part of my HTML. And this should be good enough to us to test. I will start my server. I could have some file watchers here to start the server for me, but let's keep things simple. I'll manually start to then we do that only when we really need. Here, as I load, now that I reloaded the page, I should have that console log in the page, and here it is. We have a console log client. Let's have a look in the HTML that we received. It's going to be more ugly, as we have the HTML and that entire JavaScript inside of here. And our console log, the one part of our application, is here. That's why now I have this library loaded in the browser. We got now to a point, a very good moment of a slowdown, and let's kind of look on what we have. We have the entry point for our backend. We have the entry point for our front end, and they are well integrated and well working. So it's a very good start point. This is basically where we wanted to start. Now we can actually have some real isomorphic topic. So we may now start creating content into this common folder. The common folder is the part that will be shared into both projects, and that should be visible by both. And if you have some experience with React, you probably will see where my inspiration is coming from here. I'll create a root object, and the way I like to specify components is by having some kind of a function with a name. And normally if you have React, JSX would help you on that, but no JSX here. We are basically return a string with the content that we want. And the way I will originally specify this root component is as a div with root written inside. I will also write in this component, I'll do a console log, because as this component is part of the shared library, this console log should appear in our Node.js execution and should also appear in the browser. So every time we reload the page, we should have that console log twice, once on each environment. And I will call this as root component. So this will be very interesting when we run that, how that is going to work. And we can start integrating this root component in our backend. So to integrate this component, you probably already can see, like, we are going to call the execution of that component here. I will create a component here, a div, to work as a host for this this application. This will be very helpful in the front end side as well. I will say content should be fine, and the content I'm going to print here is the root component, and I only need to import that. If we scroll all the way up, you will see that this root component, it was imported from my common folder. Now this should work in the backend side. We needed to do something similar for the front end part. So the way we can do that in the front end is now by doing a very similar code. And we are going to start this by creating a concept of a render function. For some libraries like a React or this concept of rendering is very common. So this is the function I wanted to trigger when I want to reevaluate the entire tree of components and then reset what the user can see. Most libraries, they can do that in a very smart way. They can update things in the page, only parts that changed, like React has the virtual DOM to be able to do that. But again, we are writing our code manually. We are going to reevaluate everything and switch the entire page. You will see that's actually not so bad. This approach could be an approach for a production environment. If you add the extras for security and everything, it should be fine. We don't need the libraries every single time. So it's very, very interesting when we see how that's going to work. And this render function should be called in the beginning. So as the page loads, I want the page to render. And the way we are going to do is we are going to call the document.query selector. So I'm going to query that component I just created, the content one. And in a very naive way, I'm going to inject the inner HTML as the root component. Again, I needed to import the root component, and I know that the content exists, so I will kind of ignore that warning that TypeScript was giving me. So that should be fine. We are kind of in a good moment to test. We should be able to have those things displayed in both scenarios. So that root function is going to be triggered in both environments, and that will, let's see, the way we will identify that is by seeing the console log. Let's have a look here. I will restart. Something that we will need to start doing now is we need to run the build and the start, not only the yarn start, because we changed the things in the front end project, so we needed to rerun that webpack. The way I'm going to do from now on is actually run everything, so I can run build and start all together. Then we are kind of always rebuilding everything and displaying, so that will be very simple. So you see our front-end bundle finished the building and the server started. Now, as I refresh this page, let's have a look what is going to happen. I refresh the page. We see root component executed here, and root component should also execute here. See, now I run that code twice, once in the server side, once in the browser side. And let's go here to the network and let's start looking into this this code here. So as you can see, we generated from the server side, we generated that content with the root there. So the root was already there when the when the HTML arrived in the browser. The browser recalculated the same thing and injected the same content in the page again. And we can also go into this code here and have a look on exactly how that worked. Let me scroll that better here. Yeah, so you can see here the creation of that component and injection in the inner HTML. So everything we just wrote is running in the browser. And you may be asking yourself, like, if I already have that from the back end, why do I need to do that in the front end again? Like, it's kind of irrelevant. And yes, in this current moment of the project, we are kind of replacing a content to another identical content. But one of the differences that something the backend cannot do is to inject bindings into that HTML to get the user interactions and activate JavaScript callbacks. So one example is, imagine you have a menu, and as you click in that menu, you expand to display a sub-menu, something like that. That needs a JavaScript binding into those components. And the backend is not really going to be able to inject that correctly. So we are going to have some content coming from the backend that has has no binding at all. And we are going to recreate that HTML that looks identical, but now it has bindings and has the HTML triggers, and we swap them. And then as we swap them, then the page becomes interactive. So until that swap happens, the page is there, is visible, but things that you are going to do are probably not going to work, or they are not going to be as with a good experience as if you have your JavaScript and now your bindings created correctly. So that's why this swap is important, because of the potential enhancements that you can do in the HTML. And this process in the isomorphic world is normally called hydration. So getting a original HTML content that came from the server and taking control of that to enhance that code is what people call as hydration. Different libraries have different approaches for this hydration. One example is React tends to do a smart hydration on keeping the elements in the page the same and only enhancing the elements that are already there. In things like Angular 2, they would do a full page refresh anyway, similar to what we are doing here. So different approaches, both work. I'm going to the full page refresh because that's simpler for us to write out the code. But if you wanted to create your own smart hydration engine, that feel free to do it. Share with me. I'm very curious to see how you would solve that problem. But again, this concept is very interesting, because if you go to work with Angular 2 or React in the isomorphic part, that works identical. The same process works exactly the same way. Okay, so we have now this component shared and running, and that is visible into both areas. You can see the root component is there. But one main process that isomorphic pages would need to have to be called isomorphic is the concept of a single page application. As you finish the hydration, that becomes a single page application. And the single page application means that you could navigate between sub pages in this app without actually triggering a new network call or a full page reload. So if we navigate right now for other pages, that would trigger a full page reload. So we needed to start dealing with this possibility of navigating without having the real real browser navigation. And to start that, let's actually create some concept of sub pages. Like we can create a menu with some links. We can start navigating between pages, and then we enhance that experience to be single page. Let's see how. The way I think is simpler to do it, like we can create some concept of a menu component. Again, you may recognize the similarities from React. So I'll create a menu TS. Let's see, there is some messages here. What's the advantage between loading spinner versus non-hydrate content if the user can't really interact with the non-hydrate page? That's a very good question. So normally the hydration should happen faster than the users can actually interact with the page. So for example, if you imagine a news website, you access the website and your attention will probably first go into reading the content or something. So the user would not really click on things or interact with the page in the very beginning. It's more like reading the page. And then you will still have a data time to hydrate and to enhance the page behind the scenes. So the point is, we are talking about here like saving like less than a second to the page. So if you display a loading animation for 1 second and then you show a full page that is completely interactive, comparing that with showing a non-interactive page but with all the content there for 1 second and then enhancing that page, the second option tends to be better for the experience and for the engagement of the user. So it's less likely that the users will get annoyed with your page and navigate away to somewhere else. And something that we are going to create in this page is basically the enhancement. So especially for the navigation part, when you click in a link to navigate to another page, we will have a link that works even if you disable JavaScript. So that's why even browsers that have no JavaScript engine, they should be able to work or at least have something visible to the user as some interactions available. It's not going to be the same as the full JavaScript, but it's better than nothing. And as the browsers give more features, then that experience will be better and better. Hope I answered the question. Yep, I see things make sense. Very good. And everyone in the chat, please keep sending questions like that. I think that's going to be very good. Like the point of having a live stream is to have this type of interaction with everyone. Otherwise, I would only record a video and publish that. But I like to have this kind of a conversation with everyone. Okay, so the menu component that we are going to have, so we can export a function menu, and that will work similar to the other components. I will return string, and this string will represent the menu that we are building. So I'll have here a list, and this list will have some items. And then here is the part where I mentioned, like, we will have links that are real HTML links that can navigate from one page to another, even if you don't have HTML. And the first link we can have is like something to go like to a home page, and then we can have links to multiple pages. Like we can have like page 1, page 2, page 3, something like that. I should have copied the one with page, then we don't. Page 2 and page 3. We may create a different component, abstracting only the link part as another component later. Then we can make some things smarter, like having some style for the one that is selected. Like we are going to make this as realistic as possible. And page 3. Okay, so I have now a menu. Oh, I want to save it. Yeah. Okay, I have my menu, and I will inject this menu in my root object here. So I can remove this, and I can inject the menu. Okay, so and that should import menu from common. That's it. With a quick stop start, we should now see that page with navigation. And this is one of the things also interesting from Webpack. Like we are building files we are having files in the common folder, but the entry point is in the client folder. But Webpack is smart to go and find those dependencies and bundle everything together. So that was one of the points of choosing Webpack in this project, because then we can evolve that common part without worrying about how that's going to be bundled. And here we should have our menu. So yeah, that's good. So now I should be able to click in this link and navigate between pages. And if you see the URL, you will see that I am actually navigating between pages. That's a real, and that is triggering a real request to page 3 in the URL. So you see, like, I'm calling like /page 3, and that page 3 is returning the same page. This is returning the same page because our HTTP server only knows how to return this page. There is no variation by path yet. We are going to introduce that soon. But so far, I'm having this navigation, and this is happening as a full page reload. That's very similar to server. That is the way that server-side rendered applications work, is as sending a request to the server is processing, returning back to me. Now, to transform these, or to intercept those requests and transform them into a single page application style, we will need to intercept that and deal in the JavaScript side with stopping the original request from happening, dealing with updating the URL up there, and then doing a new re-rendering of the application, so the content of the page would be affected with that part. That's what we are going to do now. The way we can confirm our next target is by clicking in those links and not having any extra network calls here. So right now, as I click in those links, you will see that I have the full page reload, and that changes and generated extra network calls. I wanted to click in those links. I wanted the URL to be affected, the page to re-render, but no extra calls. And to do that, we will need to improve our front-end library to have a concept, like we will need to be able to trigger some kind of JavaScript function to deal with this navigation for us, from intercepting the navigation, stopping the default execution, and re-rendering the page in the real path. And I think a simple way to call that function is kind of having like a go function that I provided the URL that I want to go. So that URL will be a string, and I should also receive some kind of event. This event will be important because we will need to prevent the default execution of this event, so the browser doesn't really navigate to the other page. That will make sense. I will make the event optional, because then if I'm calling this function manually, not from an event, from a button or anything, I still can use that function. And as I said, the main point of this function, we are going to check when the event exists. I wanted to prevent the default execution. So you see, prevent the default, only if that exists. I will need to update the URL on top of the page, like artificially update that URL without a full page refresh. That happens by the history.pushState API. PushState API is a native browser API, so all browsers support that. Even back to Internet Explorer 11, that already supported that. And we should be able to call that, providing some type of a state file. Don't worry about that yet. We are probably not going to use that. And the URL that you wanted to update there, and the title of the page that you want that to be. I'm providing the URL for all of those. And after you do that, like after you stop the original execution, you update the browser, we would need to re-render the page again. And that's our go function. We will need to call this function from an on-click event from those links. So the links that we just created here, now we need to generate an on-click that will call the go function. But if you have you may see already some challenges that we'll have. But let's go slow here. So the idea is on-click, I may call go. And in this first button, this is the button that goes to the home path. So I'll go to the slash, and I will provide the event as a parameter. For context, every time you have some event like this code here works as like an evaluation of this code. So basically this code is going to be executed as we click in this button. And this evaluation of this code runs with some values already as part of the context. So event there is one of those values that already exist as part of the context where this evaluation happens. And this event represents the event of the click. So that's why we need to send that event to the go function, and then the go function will be able to do the prevent default. So now we can include this go function in the other calls. Let's see here. Each one will link to a different URL. And we will also need to update some things in our webpack, because the go function was actually created as part of a module, and webpack will kind of encapsulate that function inside of the module. So the function is not actually visible to us to call like this. Like when we do that on click, this execution will try to find the go function inside of the global scope. That would be the window object, and that the go function is not going to be there. I will run that like this to represent what the problem means, and then I'll show how to resolve that in a simple webpack configuration. So here, this link is going to link to page 1. This link will link to page 2. This link will link to page 3. Okay, and I'll save. Let's build everything. And I know this is not going to work already, because the go function is not going to be available in the global scope. So everything should be there. Yeah, so now I reloaded the page. Let's go to the console. And as I click in one of those links, things will break. And as you probably saw that blinking an error message here very quickly. So basically that means I'm trying to call a go function, but that go function doesn't exist. And I will show you why that function doesn't exist. Is if we go into the script that was created here in the browser, and you will see that the go function was created as part of our module. So you see here, here is the go function. And this go function was created inside of this module here, this webpack module. So it's inside of this other function that represents the module. So you cannot really access this go function yet from something like a window.go. That is not going to work because window.go doesn't exist. So we needed to kind of expose those functions, the render, the go, and any other thing, to be available in the global scope so we can call them from anywhere. That's what I'm talking about. So the way we can do that is in our entry point for our browser here, we need to export those functions. So I will export the go function and the render function. For now, that should be enough. And I'm also going to create a updated the webpack configuration only to include extra information to tell that webpack that whatever is exported from my entry point should be copied to the global scope. So the way we do that is by having an output. So output has general configurations about how the output would work. And here we can set up a library target. When we set a library target to global, means we are building a library that should be visible in the global scope. And that's it. Now our go function should be visible to anywhere in the application to call, even outside of the webpack modules. Now things should work. If it breaks now, then I missed something else. And let's see how things go. I will do a full page refresh. Now, if I click on page 3, let's see. Oh, you see here, page 3 updated in the browser. So I can now click into multiple pages. You see that the root component is getting called. So I am re-rendering the page in the browser. And if I go back to the network and I click and I clean up the network calls, I will start navigating here. and you will see that the only thing I'm getting updated there is the favorite icon. That icon is like the browser is trying to find an icon to display here in the title. We may remove that call later to reduce the noise, but at least the page itself we are not calling. Like now we have a single page application here. This is navigation happening only in the JavaScript part that affects the URL and re-renders the page. But as you probably can see, like it's still a bit harder to see that navigation happening because all those pages, they look identical. Like they all have only the menu. There's nothing else, no title or nothing, no difference in those pages. So my next target is to make those pages different enough. So when I have that navigation, we'll be able to see them better. And the best way to do that is we will start having like some concept of routing, similar to React. If you worked with React Router in the past, like you may have some components that needs to match to a URL. So depending on that matching, you render something or something else. So that's the kind of idea that I have right now. And to be able to have this routing, we will need to have access to the URL. Like we will need to know where or what we are trying to render inside of the root component. So let's go back here. So our root component will need to somehow know the URL. And that's what I mentioned before. Like it's kind of hard to the root component to know that, because if this code is going to run in Node and in browser, the ways to discover the URL is different on each one of those platforms. So we will need to create some extra code in those two entry points for browser and server to provide the URL to the root component. Let's start with the index, because the index is probably going to be a bit simpler. So you probably remember I mentioned that the request is the representation of the message that the browser sends to the server. So inside of the request object, there is a field that is called URL, and that field is the intention is to tell the server what we are looking for in the server. This URL is going to be the complete URL with the parameters, like the attributes, parameters, everything, like the full URL. Right now I'm interested only in the path name of that. So the simplest way to deal with that is to use a native Node.js parser. So we can get the URL from URL, and we can use this to parse the URL for us. So I can do a URL.parse, and that is going to provide that for us. And here is saying that the URL may be no. I know in this project that that's not the case, so I will kind of ignore that error. If you are in a real project, don't ignore the error and actually provide ways to deal with that. And this parse will return a complex object with a lot of information inside. I'm not interested on everything in that object, so I'm going to only pick what I need, that is the path name. So that's the only thing I need. And we can use this path name and we can call the root component providing the path name to the root component. So now we are giving that awareness to the root component. The root component doesn't really need to know where the path name came from, only needs to know that it exists and needs to deal with that. So we can update our root component to receive this path, and that is going to be a string. And because I updated the root component, that will fail the build of the browser part, because the browser also needs to provide that. The way that the browser will get the path name is by using the document.location. And document.location is also a complex object that has all the path related things, but I'm not interested on that. So I'm only interested in one part. So I can do a very similar code where I also destructure that object, get only the path name, and I provide the path name to my root object. So then now you can see that basically the root object as a reusable library doesn't need to know where that path comes from, only will use that path name internally. And to confirm if everything is working, I'm going to print this menu, and I will print just next to the menu the path name itself. So we will be able to see something changing in the page as we navigate from one page to another. Something will be affected there. So here I can display the path, and that should be good enough for a test. Let's see how that works. Okay, something didn't work. Let me see. See, this is the part I like about the TypeScript, because normally those things are very simple to understand. We have a string or no assignment. So something in the server is not correct. Yeah, path name. So that means that path name may be no, and I don't care about that. I know it's not going to be. So because we have a very controlled environment, I know that path name is not going to be no, so I can ignore that warning. But in a real environment, that is a very helpful thing. So you don't send code to production to see that error happening for your users. Okay, so we should be able to see the page updating now with the path here, and yes, we can see this. So as I navigate now from one page to another, you see that path affects there, and that is a really good thing to see. Like if I force the full page refresh, that will load the page tree from the server, and you see that the page tree was created as part of that page. But from this point in time, I will be able to navigate to other pages like page 2, and I don't have another network call. Nothing needed to go to the server. If I force the refresh of the page, yes, I call the page 2 from the server, and the page 2 will be created. This is an interesting point, and going back to Chester questions from before, I'm going to now disable my JavaScript, and you will see that the application still works. Like everything should still be fine, but without the JavaScript enhancements. So I will do a full page refresh. Now we go back to the point where the JavaScript doesn't exist, but you see page 3, page 1, home. So page is still working. Is working in a slightly less ideal way, but works. And then as the browsers of the users provide features and JavaScript and everything, the difference for them is that the experience will be better, so will be faster or will be smoother for the users, but they are not really getting much features than everyone else. And now with this, I reload the page, and now I can have that same navigation, the same feeling should be there. All good. So let's see. I think we can now go into that routing system. So the idea is we should have some more complex page for each one of those pages, like home, page 1, page 2, page 3. Let's have some more complicated page. And then as we have a navigation between them, that's going to be a more realistic application. So let's start here. So we can create a new component. I'll create like a home component. This home component will be a very simple and that will return and the main thing I would say here is home, so because I don't have much else to say. So as we can navigate between pages, like if we see that the title changing, that's going to represent that things are working fine. And what I'm going to do, I will duplicate this component as well. So I will get the page 1, page 1 component. I also needed to rename the function and the title. So here we call page 1. And now I can duplicate this page to page 2, page 3, page 4, or whatever. Page 2. Page 3. Okay, so here we are. Now we can see page 2. I will rename the function and the title. And page 3 also. We will need to, the root component is still going to be the entry point for everything, and that's where we are going to have our routing definitions there. So let's have a look. Yeah, this should be good. So now let's create this routing here. So the page, all pages will have that menu anyway, so that's part of the main template of the page. And we can remove this log now. Let's start defining our routing. So I'll create a const routes. That will be a key value pair. These routes could be outside of this function. That's probably going to be better if create outside. And the idea is I'm going to create something like the simplest way possible. The key of this object will be the path itself, the path that I want to match, and the value will be the object that I wanted to execute. So when the path is only a slash, that is the home. So, and I don't want to execute this here, I only want the function here. If I have a path slash page 1, then I want the page 1 component, and so on. So we should let me duplicate this line, will be easier. So then we can have a page 2 and page 3. And then what we are going to do is we are going to use the path that we receive from the environment, and we are going to use that to search in this routes key value object to see what we should render. So let me import those two things. And now we have our routes set. So we can use, we should have some type of default route if we have like if we try to access a page that doesn't exist. How are we going to do that? Let's create something as well. I'll create like a error page, and I'll say, I'll give a message like page not found or page doesn't exist. That would be interesting. So I'll call here not found. Yep. So we will also need to register data here in our routing. So if we try to access something that we don't recognize, we can switch to this error page. And of course, if we access from the browser /error, we also load the error page, so both will be fine. Here it is. So now we have the path. The idea is that we may get the page handler or the page component. I'll create as a let, so then we can swap if we have an error. So page component will be what we are going to get in the routes in the path. And we can say if we don't find anything, then give me routes error. That should be good enough. What we have here, some warnings. Should be fine. The error was okay. Let's ignore that. That's kind of a trick to... Did I misspell anything? Oh, let's see. Should work, or let's see when we run. Maybe things will find out. I don't want to go deeper and understand what is going on there. we would get that path component and we execute that, and that should display. So now we don't display the URL anymore, we only display the execution of that path. Let's see this error again. So the element implicit has any type. Ah, yes, okay. You are saying that this object here has implicit any because the TypeScript default object has a strict mode. So we should specify that this object has a key string and value is a function. So it's a function that returns a string. With that definition, things should be fine. Yeah. See now, and I actually, because I did that via like the error handling in the same line, this actually doesn't need to be a let, we can have that as a const. Okay, here we go. We should be able to have everything working fine now. Yeah, we build way more components as we go. And I'll refresh this page and we have a home page. And as we have a home page, now I should be able to navigate between multiple pages. And you see the only network traffic we have is that favorite icon. No extras are called. But if I manually go to a page that doesn't exist, we have not found. So I think we are kind of in a very interesting point of cut now for this first live stream today. We have a working application. We can navigate between pages. We have that front end hydrating the page and taking care of the single page aspects. Also having the back end working fine. Even if we disable JavaScript, we are able to do the full page reload. And from the user's perspective, having JavaScript or not in this application becomes irrelevant. That works anyway in both with or without, but definitely having the JavaScript aspects will provide a better experience, and that's the best approach for the applications. Like if you can take advantage of the current API available to you in the browser that the user is using right now, you still have a value to be delivered to the user, but that wouldn't stop users with older browsers. Like the current application I take care in my everyday work, I need to support Internet Explorer 11, and that's a very challenging thing. Like being able to have a working application for Internet Explorer users is very complicated because it slows down how the latest features that we can include in the app. But if we make those latest features still available for newer browsers and only find out a different way to handle that for older, everyone can get some value from your application. I think I will post this project in GitHub. That is going to be where we are going to pick up next week from this point. But I also wanted to ask if you in the chat, or if you are watching this later and you have some suggestions on how we should call this framework or this library we are building, then we can publish that as in GitHub with the name we choose. Send me the recommendations for the names that you like, and I will pick the best ones, and you can run a poll to choose that next week. Also, we can go now into more chatting mode. Like if you have any questions, even other topics non-technical, that will be very nice to cover. I also should go do a quick catch up to see if all the live streams are working fine. And yeah, I think most of things worked okay, except Twitch. Unfortunately, Twitch didn't work. I'll need to find out, but next week I will probably have fixed this problem with Twitch, and we should be able to also stream there. Any questions in the chat? Any things that you wanted to cover, extras, not only related to the project? I'll give you some time because of the delay in the stream. And again, thank you for being here, everyone. I think it was a great first stream. I'm very happy on how that went. I hope next week we can have more people, so share the link with everyone. The video offline should also be helpful on sharing that. And the next things we are going to build in this application is trying to have that as a more realistic app, like maybe create, update, and delete, calling some REST APIs, having some kind of a more interactive application. Today was very setting up the project, so if you know a bit of a front end, this first session was probably a bit boring, but from this point we should start going deeper and deeper into the topics for Isomorphic. And that's, yeah, I see some comments in the chat. Thank you, everyone. I will assume you have no questions or things right now, but if you have later, write in the comments. The main point of the live stream will be YouTube, so ideally if you can go to the YouTube page and write your comments there will be simpler, but any one of the other platforms is also welcoming. And I will probably stop from here now if you guys don't have other questions. Final thank you